12.2 Surface area of prisms and cylinders. So I will start off with a little bit of vocabulary. It says that a prism is a polyhedron with two congruent faces called bases that lie in parallel planes. We're looking at our figure over here. We have an octagonal prism, so our bases are octagons. We have base 1 here, and we have base 2 here. So base 1 is on the top, base 2 is on the bottom. And then it says that the lateral faces of a prism are parallelograms formed by connecting the corresponding vertices of the bases. When they're talking about lateral, you need to think of up and down. So when it says lateral faces here, lateral faces, think up and down. We're looking over here at our figure. We have vertices between our bases. So we have a vertex here, and a vertex here, and another here and here. So this here, this rectangle, it looks like a rectangle at this point. You can think of it as a parallelogram as well. But lying here, this is our lateral face. So this is our lateral face 1, and if you would count them up, these are all that go around the sides. We'd have 1, 2, 3, 4, 5, 6, 7, 8. So the number of lateral faces that we have matches up with how many sides we have with our base. So in this case we have an octagon, so we'll have 8 lateral faces. And it says that the lateral edges of a prism are the segments connecting the corresponding vertices of the bases. And I'm going to erase this stuff on here now. And what we have when we're talking about the lateral edges, remember this is a lateral face here, so we're looking at this here. We have our lateral face. So between these 4 vertices lies our lateral face, and the lateral face is here, and the lateral edges run between the vertices, so they go here. This is a lateral edge here, and we have another one over here. So they are the edges, they go between the bases. So those would be your lateral edges. And we have some more vocabulary. We're looking at a pentagonal prism, which means that we have a pentagon, so 5-sided shape, as our bases. It says that the surface area of a polyhedron is the sum of the area of its faces. And it also says that the lateral area of a polyhedron is the sum of the areas of its lateral faces. If we're looking for the entire surface area, we'd have to look at all of our lateral faces. So we have 1, 2, 3, 4, and 5, as well as our bases. So we have a base here, so our base 1, and we have our base 2. So we're looking at the top and the bottom. So we have to add up the top, the bottom, and all of the sides, all the lateral faces, and that's going to give us our surface area. And if we're looking at a 3-dimensional figure and we want to break it down into 2 dimensions, we use something called a net. And a net is a 2-dimensional representation of the faces of a polyhedron. And we will get to an example of a net in one of the examples at the very beginning. So don't worry, I'll show you a representation of what that looks like. Let's look at prisms. So in right prisms, it means that each lateral edge is perpendicular to both bases. If we look here, we'll look at our both of our figures here. When we look at this one, we have a lateral edge that runs here between both the bases, and what it means when it means they're perpendicular, that means that it creates a right angle. So these are right angles. So between all the lateral edges we have right angles, therefore we have a right prism. If we have an oblique prism, an oblique prism is a prism with lateral edges that are not perpendicular to the bases. If we look at our first example of an oblique prism, you can see clearly at this angle, this is not a 90-degree angle, and neither would this angle here. So these are oblique prisms. So for the first example, it says, find the surface area of a rectangular prism with height 2 centimeters, length 5 centimeters, and width 6 centimeters. What I'd like you to notice first, down here at the bottom, it says to sketch the prism. When you guys are doing this on your homework, I don't expect you guys to be perfect artists. I'm not a perfect artist, but for this example, I wanted to show you what the perfect example would look like. So right down here would be what your rectangular prism would look like. And since it's a rectangular prism, that means our bases are going to be rectangular. So this right here, this is our rectangular prism. Now, when you unfold it, so if you were to unfold this rectangular prism, we would have a net, and this is a net. So this here is your net. What I'd like you guys to think of when you're thinking of a net, I'm sure most of you guys have unboxed something at one point, and when you look at the box, you can cut it and you can unfold it, so you're going to get a flat two-dimensional representation of your three-dimensional box. But our problem says that we need to find the surface area. So if we're going to find the surface area, we need to find the area of the lateral faces as well as the bases and then add them up together. This problem looks very involved. If you look at this, it looks very, very involved. However, all we need to do is find the area of one of the bases and then one of the lateral faces, the other lateral face, and we can multiply them all by 2. So if we look at these, this is 1, that's a base, this is 2, that's one lateral face, and this is 3. So if you look over here at the rest of our net, this is identical to 1, this is identical to 2, and this is identical to 3. So once we find the area of 1, 2, or 3, then we multiply it by 2 since we have them double. So we find the area of 1, we'd have 5 by 6. So 5 by 6, so 5 times 6, and that is down here. So the area of the top and the bottom, we do 5 times 6. So the area of the left and right faces then would be 6. So we have 6 by 2, so 6 by 2, and you can see that here, 6 by 2. And finally, the last one we have left would be 5 by 2. So we have a 5 here at 3, we have a 5 by 2, so 5 by 2. And remember, this is only finding the area of one of these faces, and since we have 2 of them, we would multiply each of these by 2. So you'd multiply each of these answers by 2. And when you multiply by 2, you can add up all the areas, and that's going to give you your surface area. So we did the first one, so 12 times 2 plus 2 times 10 plus 2 times 30, and that will give you an answer of 104, and it's centimeters squared. We're finding the surface area. Surface area, so your units should be squared. For the third example, it says find the surface area of the right pentagonal prism. And this problem looks very complicated, very involved. However, we have done this in 11.6. So let's get started. The first thing it says to do is it says to find the perimeter and area of a base of the prism. So we need to find the perimeter because the perimeter is involved in the area. And if we were to find the perimeter, so our perimeter, so P, is equal to the number of sides. So I have a pentagonal prism. So I have 5 sides multiplied by the side length, and my side length here is 7.05. So I have 7.05. And when I multiply these together, I should get 35.25. And that is going to be my perimeter. So now that I found my perimeter, I can find the area. And what I would suggest doing when you're finding the area, we need to follow the steps in 11.6. Therefore, that means we need to follow, we need to find the central angle. And if we were to find the central angle, we would do 360, and we would divide it by the number of sides, and that'd give us our central angle. So therefore, we would know what our central angle is. And at this point, I'd like to blow up this triangle here in our pentagon. So I'd like to blow up this triangle. So if we come down here, we know that each of the bases is a regular pentagon. I should have mentioned this at the beginning of the video. You can see that all of the sides are congruent. Here you can see all of the sides in our pentagon are congruent. Therefore, that means we have a regular. So we have a regular, or right, regular pentagonal prism. So each of these will be regular. I'm not going to throw anything that wouldn't be regular at you. Okay, at this point, now that we've blown up our triangle, we can drop this line here. Remember, it goes from the center to one of the sides and creates a right angle. This is the apothem. So we drop down an apothem, and the apothem cuts the central angle and the side length in half. We know our side length. We found that in the perimeter. So our side length is up here, and that's 7.05. So we divide that by 2, and we have 3.525. And that is going to be half of our side length. So to solve for A, I know two sides, therefore I'm going to use Pythagorean theorem. So I have A squared plus 3.525 squared is equal to 6 squared. And therefore I need to solve for my A. So I have A squared plus 12.4256 equals 36. And this is something that, remember, we've worked on and mentioned in class. We want to be as exact as possible. Therefore, I'm going to go out to 4 decimal places. And from this point, I can do 36 minus 12.4256. And I will get A squared is equal to 23.5744. And when I square root this, I will have A is equal to 4.8553. So remember, wait to round until the very end, otherwise it could mess up your answer and you would be way off. And from this point now, since I have found my apothem, I can now find the area of my polygon. So when I find the area of my regular polygon, I have the area is equal to 1/2 the apothem, which is 4.8553, multiplied by the perimeter, which, remember, in the perimeter we found is 35.25. And when I multiply this together, I need to remember that I have 2 of these, so I have 2 bases, so I need to multiply this by 2. So multiply this by 2. So your final answer for the surface area, or for the area of your polygon, should be 171.14, and that's feet squared. So from here we found the base, and that's the area of both of our bases. So we have both of our bases. Now we need to find the area of the lateral edges. If I were to find the area of the lateral edges, you can see, since it's a right pentagonal prism, I'm going to erase what I have written on my figure here. So we have a right pentagonal prism. What that means is our lateral edges create 90-degree angles with our bases. So if we have 90-degree angles, that means we have rectangles. And for the rectangles, what we'll need to do, so for the lateral faces, so we'll call this the lateral faces area is equal to, we would do the base times the height. And we know the base, it's the side length here, it's the side length of our pentagon. So that's going to be 7.05, so 7.05. Multiply that by the height, and we can see the height. The height is here, the height is 9, so height is 9. And I would need to multiply that by the number of lateral faces that I have. So I would have, I'm going to come up here and count them just so I'm exactly sure. I have 1, 2, 3, 4, 5. So that matches the number size of a pentagon. So I'd multiply this whole entire thing by 5. And what I would get for my lateral faces area would be 317.25 feet squared. And so to find the entire surface area, and surface area is when we could think of like wrapping paper. If you wanted to wrap, so cover this entire prism, that's what the surface area, you need to find the surface area for that. So we're trying to cover the entire prism, top, bottom, and the sides. And to do that, we have two parts, so we need to take those two parts, we need to add them together. So to find the surface area, so we take these two parts to find the surface area. Surface area is going to be equal to 317.25 plus 171.14, and when you add both of those together, you will get 488.39 feet squared. Remember, it's feet squared because we're dealing with surface area. So that would be the surface area of our right regular pentagonal prism. Next example here, example 3, it says you're wrapping a stack of 20 compact discs using a shrink wrap. Each disc is cylindrical with height 1.2 millimeters and radius 60 millimeters. What is the minimum amount of shrink wrap needed to cover the stack of 20 discs? So we're dealing with a cylinder here, and what you're stacking, compact discs, so CDs, you're stacking 20 CDs. And so the height of our cylinder would be those 20 CDs multiplied by their height, which is 1.2. So we'll look down here at the solution, and that would mean that our stack would be a total of 24 millimeters high. It also gives us the radius, which is 60 millimeters, and we're trying to find the minimum amount of shrink wrap that is going to be able to cover our compact disc, so we'll need to use surface area. For cylinders, there's a formula. So the formula is the surface area is equal to 2 pi r squared plus 2 pi r h. And at this point here, the cylinders are a little bit easier because there is a formula. You'll have to memorize the formula, but there is a formula, so that it's going to be easier than finding with our prisms. So at this point, I can just plug things in. So I have 2 pi. Most of you guys, I would try to use the pi button if you can. If you have the pi button on your calculator, use that. If not, you can use 3.14. So we have pi, and then our radius, which we said is 60 squared, plus 2 pi radius, which is 60, times h, little h, so that's height, and that's 24. So after you multiply this all out together, you should get 31,667.25 millimeters squared. Don't forget the units, millimeters squared. So this is a cool formula because it's pretty easy to prove or to show where it comes from. So if I draw a cylinder, my artistic skills are very lacking, but we'll draw a cylinder. So we have a circle at the top for one base, we have a circle at the bottom, connected by sides that wrap around. So if you think about the area of a circle, the area of a circle would be pi r squared. So that's the area of a circle. We have 2 circle bases. So we have base 1 here and base 2 here, so the top and the bottom. So that means we have 2 circles that we need to find the area of. So that's where 2 pi r squared comes from. And if you were to create a net or unwrap a cylinder, the side that wraps around, so the side that goes around. So when we go around, if we were to go around this way, these sides, so if we were to wrap it around, it actually creates a rectangle. So we'd have a rectangle, and the top of this rectangle, so the we'll call it the length, would be the circumference of a circle. And if you remember the circumference of a circle, that's going to be equal to 2 pi r. And since we have a rectangle, it's base times height, so this could be the base here. The base is here. So we need to find the height, which is just h. Therefore, altogether, we'd have 2 pi rh. So this is very similar to finding the surface area of a prism. We find the area of the parts, and then we add them together. So for example 4, it says find the height of the right cylinder shown, which has a surface area of 157.08 square meters. We're given the surface area, so we would plug that into our formula. So the surface area would be 157.08 is equal to 2 pi. Our radius, so we're finding the area of our bases first. So we do 2 pi r, which is 2.5 squared, plus 2 pi r, which is radius, which is 2.5, and what we're solving for is h, or the height. So coming down here, when I would simplify this left side, I would have 39.2699 plus 15.70796h. Once again, if you guys would notice, I am using exact, or as close to as exact as I can get. I want to make sure that when I'm rounding these, I'm not rounding to tenths or even hundredths. I'm going out at least 4 decimal places to keep my answer exact. So at this point, I would subtract my 39.2699. I would subtract that, so I would have 117.8101 is equal to 15.70796h. And then I can divide both of these, so I can divide on both sides, and I would have 15.70796. And I divide 117.8101 by 15.70796, which would mean h would be roughly equal to 7.5 meters. And it's a dimension, so it would just be meters. So as you guys can see, these surface area problems can be challenging at times. However, there is a formula, so we can use the formula on the cylinders. But it's important that you guys are practicing these. And remember, wait to round until the very end to keep your answer as exact as possible.